So yes, you have done this lesson before. We did it very briefly, and it was back in first semester, and I'm sure that you probably forgot most of this. So it is going to look familiar. We're going to go into a little more detail today because you're going to need more of these strategies we do today for the next few lessons. So I'm going to show you multiple ways, and you're going to need to write them all down because only certain ways you'll be able to use later in the chapter. Okay? So there's going to be a little bit of writing in our first few slides, and then after that, it'll mostly just be numbers and examples. So stick with me. The first slide is going to look like a lot, but it's not that much. It's just 2 sentences. So when you write a decimal as a fraction, decimals like 2/10, 34 hundredths, 15 hundredths, and 456 thousandths can be written as fractions with the denominators of 10, 100, 1,000, and so on and so on. Any number that can be written as a fraction is a rational number. Yes, you need to write this down. It's only 2 sentences. If we have decimal numbers that have a whole number, like 3 and 25 hundredths, or 26 and 49 hundredths, they can be written as mixed numbers. Remember, mixed numbers include a whole number and a fraction. Okay, we're moving on. All right, so let's write decimals as fractions. You don't have to write the whole sentence out. Just put on your paper 0.6 or 6/10. Just write that part. Okay. And the first thing you're going to do is write all the digits that are behind the decimal as your numerator. So in this example, we only have 1 digit behind the decimal. That's that 6 there. There's only a 6 there, which means your numerator is just going to be that 1 digit, that 6. If there were 2 digits there, we'd have 2-digit numerator. But we only have a 6, so the 6 is our numerator. Thank you. Sorry. Depends on the level I put it at. All right, you ready for step 2? All right. So, step 2 is the denominator is going to always start with a 1. Okay? We've got our numerator, it's the number behind the decimal. The denominator is going to be different each time, but it's always going to begin with the number 1. So we're not done yet. Our fraction is not 6 over 1. It's just the beginning of our denominator. Step 3 is how we figure out the rest of our denominator. And that is however many numbers that are behind the decimal equals the number of zeros in our denominator. So again, we only have this one number here, this 6. So since we have one digit, we're only going to have 1 0 in our denominator. 10. And there's only one more step after this. It is. And your last step is always your last step when we have fractions or ratios or rates or anything written with a numerator and a denominator, and that is to simplify. So if we have 6 over 10, you know we have to divide by the GCF. Anyone see it quick without writing all the factors? What is it? What's the GCF? 2. So we're going to divide the numerator by 2 and the denominator by 2, which means yes, savvy. Our final answer in simplest form is 3/5. So 6/10 or 0.6 as a fraction in simplest form is 3/5. Now there's another way to write a decimal as a fraction. This way only has one step. Okay? And you're not going to write all this down. I just want to show you some of it. What I want you to write down right now is 0.45 or 45/100ths. Write that down. What I do not want you to write down is this chart. Okay, this place value chart. You've been looking at place value charts since, I don't know, first grade, maybe you saw them. Hopefully last year you saw a place value chart that has a decimal in it and the places behind the decimal. So before you had ones, tens, hundreds, thousands, so on and so on and so on. And then in 5th grade, we went the other direction behind the decimal. Tenths, hundredths, thousandths. Okay? So I have this number of 0.45, and I've written it on our place value chart. You can see that my tens and ones are zeros, the decimal point. I have 4 in the tenths place and 5 in the hundredths place. The reason this is important is because the way that you write this decimal as a fraction is just to say the decimal place value. So if you read this decimal correctly, you would read the number up there, which is 45, and then you say whatever digit is last, the place that it's in. So our 5 is our last digit, and the 5 is in what place? The hundredths. So we would read this as 45 hundredths. I want you to write down the words 45 hundredths. By saying the decimal with the place value, 45 hundredths, you've just told me what the fraction is. It's 45 hundredths, or 45 over 100. Thank you. So just by reading it properly, we know what place each or the last digit is in, which means you know what the denominator is going to be. Hundredths gives you 100. If it was tenths, it would give you a 10. So only one step, and you're done. Correct. Always simplify. The GCF of 45 and 100. Anybody want to take a guess? It actually is 5. No but. However, if you were not knowing the GCF here, or you were just guessing, I would pick an easy number to divide by. 45 ends in a 5 and 100 ends in a 0. What can always go into a 5 or a 0? A 5. If a number ends in a 5 or a number ends in a 0, we can always divide by 5. So that would have been a good place to start, but it just so happened that the GCF was 5. So divide the top, divide the bottom by 5. We're going to get the simplified version of 9 over 20, or 9/20ths. Now it's your turn, without me showing you how to do it. I want you to write down 9 and 85/100ths in your notebook, and I want you to write it as a fraction. Now, I didn't give you anything with whole numbers yet, but there was a note you wrote at the beginning about whole numbers in there. Example, I want you to write down 9.85 and write it as a, yes. I want you to write it as a fraction. For 100 XP, would someone like to go write it on the board? Let's start with what you got first, and then we'll simplify it. So the beginning of your note said if you had a number like 3 and 25/100ths, it would be written as a mixed number. You should remember that a mixed number has a whole number and a fraction. If we looked at this like money, it would say $9.85. We know that cents is out of 100. So we could rewrite that as $9.85 out of 100 cents. The 9 is still $9. It's still a whole number. So just because we're converting to a fraction doesn't mean the 9 is going to change. So nicely done, the 9 stays the same. And then 85/100ths, or 85 over 100. And then we have one more step, which is to simplify. Five is the GCF. And you end up with 17 over 20. 9 and 17 over 20. Don't forget that whole number. There we go. Excellent. 100 XP. Don't worry, there'll be another chance for someone else on another one. Today? Yeah, today. Well, we got to go through a few more things because we went from decimal to fraction, so now we're going to go the other way. We're going fractions to decimals. So step one is there's two methods to this, by the way. This is the first method. And the step one is to write an equivalent fraction with a denominator that has 10, 100, or 1,000. We know how to write equivalent fractions. You've been doing it with ratios and rates for 2 weeks. You took a test on it. Every time you simplify, that's an equivalent fraction. So we have to find another fraction, but the denominator has to be 10, 100, or 1,000. So if I have 9/12 here, let's start with the first number it could have as a denominator, which is 10. What can I do to 12 to get the answer of 10? Nothing, right? You can't divide by anything to get to 10. So that is not going to work. But we can move on to the next number. What about 100? Can 12 get to 100? Is 12 a factor of 100? It's not. You can't multiply 12 by anything to get the answer of 100. Same with 1,000. So we have to go back to what we did last week by moving backwards to go forwards. So when we move backwards, we are trying to find the unit rate. If we cannot, it would be just the simplest form in this case. So let's simplify 9/12, which means we're going to divide the top and the bottom by 3. 3 is the GCF. Divide by 3, divide by 3. We have a simplest form fraction of 3/4. So now we have it in simplest form. And just like we did on those ratio tables, we have this equivalent fraction that now we can use to find our new fraction with 100 as the denominator. Now, I could try for 10, but you should all know that 4 cannot get to 10, right? 4 times nothing will get you 10. So let's go to 100. You should automatically know 4 times what is 100 because money, quarters. How do you get from 4 to 100? Times 25. 4 times 25 will get you 100. 4 quarters is $1, right? If we multiply the bottom, we have to multiply the top by the same thing. So 3 times 25 equals 75. So now we have finally got our fraction that has a 10, 100, or 1,000 as the denominator. This one has 100. Great. We have our equivalent fraction with 100 as the denominator. Big deal. We're not done. Well, we started with a fraction. We can't end with a fraction. We're supposed to end with a decimal, right? So step 2 is the numerator is your decimal. If we have 75 over 100, it's going to be 75 hundredths, or 0.75. Your answer is the numerator with a decimal in front of it. We have another way to convert a fraction to a decimal. I think you'll like this way better. We divide. We divide. Remember this one? When you divide, you just divide the numerator by the denominator, or the top number in the house. Remember I yelled that at you the first semester, like every day when we did decimals and fractions? Vaguely. Top number in the house. So if I'm going to use the example of 9/12 again, I'm going to divide 9 by what? 12. So the top number is going to go inside. The 9 goes inside. The 12 is on the outside. So my math problem looks like this. 9 divided by 12. Now this next step I'm going to go through quick because you all know how to divide decimals. Right away you know that 12 cannot go into 9. It's too big. So we have to say 0 times, right? 12 times 0 can't go in. But we have to do something to that 9 now. What are we going to do to the 9? Annex a 0. But before you annex a 0, you have to put what behind that 9? A decimal, right? Because if you just put a 0, now we have 90. We need a decimal and annex a 0 because this says 9.0, which is the same as just 9. We haven't changed anything, right? And it's very important you remember to put that decimal on the inside because then it goes straight up on the top. And this is where the decimal is really important, is make sure it is on the top in the right spot. Now we're just going to divide as if there were no decimal. We're going to look at this and say 90 divided by 12. What's 90 divided by 12? 7 is the correct answer because 7 times 12 is 84. And then we subtract, right? It's all coming back to you now, right? 90 minus 84, 6. We're not done because you are not allowed to have a remainder. So we're going to annex another 0 and bring it down. Now I have 60 divided by 12. 5. Excellent. 60 divided by 12 is 5. 12 times 5 is 60, and we subtract. You end up with 0, nothing left, nothing to bring down, which means your answer is on top of the house, 0.75 or 75 hundredths. You like dividing or you like equivalent fractions better? Dividing. Okay, here you go. Do this one in your notebook on your own. Write 3/5 as a decimal. I'll have someone come up and do it for 100 XP. Well, there are 2 ways to solve this. Go ahead, Charlie. So, top number in the house. Decimal annex your 0. 30 divided by 5. 6 times 5. Subtract 30 minus 30, 0. 6/10 is your answer. Nicely done. For 100 XP, who would like to do it using equivalent fractions? All right, Savvy, you're the only one. Go do it. I would have done it this way too, and I'll show you why. Haley, take your hood off. What does the denominator have to be? Say it again. 10, 100, or 1,000? Does 5 get to 10 really easily? Just times 2. So 5 times 2, 3 times 2, 6 over 10. Your numerator, which is 6, becomes your decimal. 6/10. Didn't even have to divide on that one.